Okay, here's 7.3. It's on adding and subtracting rational expressions. And you might remember rational expression as a fraction. And when you add or subtract a fraction, do you remember that their denominators have to be the same? So that's what we're going to be dealing with polynomials. So let's get to it. And so a lot of similarities between real fractions and polynomial fractions. Dun, dun, dun. Right? Okay, so adding and subtracting. And so I just wrote out, like, things to think about. And so it's not really a step-by-step, but, you want to think about that the denominators must be the same. And people call, when the denominator is the same, they call that the LCD, or they say, I'm going to get the lowest common denominator, or the least common denominator. And just a general, how you find the least common denominator is you factor the denominators. Notice the F word there, factor, right? And so, and then you can build the lowest common denominator or the least common denominator. People use both words from those factors. And the LCD must have every factor of both denominators, and you can extend that to 3 or 4 or 5, 6, 7, 8, 9 denominators, however many you have. And then how you make the denominators be the same, well, you have to make equivalent fractions. And you might remember from regular fractions that what you do to the numerator, you got to do to the denominator, and vice versa. So you can make equivalent fractions by multiplying or dividing both the top and the bottom by the same amount. You only multiply or divide, you never add or subtract to get equivalent fraction. And then once the denominators are the same, you add or subtract the numerators over the common denominator. And I just make a note that you have to be careful when you're subtracting, because you have to distribute the negative and then combine like terms. And then simplify, and then remember, this is how you simplify. You factor the numerator, you factor the denominator, you reduce the pieces that are exactly the same. Okay, and remember, if they're exactly the same pieces, when you reduce them out, you're getting 1. Okay, so we're going to give a try, and we're going to start off with ones that have the same denominator. So this is problem 16 out of your book. X squared minus y squared is the denominator, and you notice, okay, the denominators are the same. So I don't have to do step 1, which is to get the denominators the same, because they are the same. So I can go on to step 2, where I add or subtract, in this case add the numerators, so x plus y, those are the numerators, divided by the common denominator, x squared minus y squared. So I didn't have to do step 1, other than notice that the denominators were the same. Step 2 was to add them together. I've done that. Step 3 is to simplify. And this is a binomial. So it can only reduce with the denominator if it is a binomial that is exactly the same, or can be factored to be the same. So x plus y doesn't factor, but x squared minus y squared is a difference of squares, right? So I got to reduce this, and how you reduce this is because it's binomial, by factoring the top, which doesn't factor, so I like to write x plus y, and factoring the bottom. Well, the bottom is a DOS, a difference of squares, so that factors as x plus y, x minus y. And then if you have any pieces that are exactly the same, you can divide them out. So x plus y divided by x plus y is 1. And so we end up with 1 over x minus y. And that's our answer. There's nothing more that we can do on that. So we did a lovely job on that. I wanted this example right here because they really do have a lot that reduce, a lot of them that reduce. And I wanted you to see that they don't all reduce. And so, and they kind of, in a certain section, it's like they all reduce, and in a certain section, they all don't reduce. So here I would have x plus, this pencil is having trouble. We'll get another one here. X plus 4y over the same denominator, x squared minus y squared. And so the same thing. The numerator still doesn't factor, just like it didn't factor here. So you could put parentheses around it if you wanted. sometimes I like to put the parentheses around it to tell myself this is one thing altogether, and that if it's going to reduce, it's going to be the whole thing that reduces with another binomial, and that I can't reduce the x with like an x or something. And then the denominator factors, remember, x plus y times x minus y, it was a difference of squares, so no different than over there, right? But now these are not the same, so they don't reduce with one another. So this is my answer. Now when I look in the back of the book, they're not going to write the parentheses here because they're not necessary, but it's not wrong to write them there. And if it keeps you from reducing when things don't reduce by telling yourself that it has to be exactly the same as x plus 4y, then I think that's a good idea. So here is one that is a subtraction, and so when you have a subtraction, this minus right here, there's invisible parentheses here. They're implied. They're actually here too. And so this is really, if I wrote it, you know, I get too lazy to write the whole thing, but I'm going to write it this time. If I wrote it so that you can see what was happening, I have this subtraction of the numerators over the common denominator. And so then you distribute the negative. So this would be, and some people like to put a 1 here when they distribute. If you do, great. And so when you distribute, you get negative x plus 6 all over x plus 2. And then 2x, take away x is x. And minus 4 plus 2 is 2. And I have x plus 2 divided by x plus 2. And hot diggity dog, that's 1, right? This is a binomial. This is a binomial. They're exactly the same. When you divide them, you get 1. And so there we did a good job on that one. And so let's look at 17 here. And so what I usually do, I wrote it there here so that you can see this is what it was. But what I usually do is I usually do this, 2x minus 3, and then I distribute the negative when I have it. So that'd be minus x plus 1, all divided by x minus 2. Why did I do both of these? These are almost the same problem. 2x minus x is x. Negative 3 plus 1 is negative 2. I wonder about myself. And so these reduce with one another and give you 1 as well. So anyway, okay, so we did a lovely job on that. Then this one here is just regular fractions to reduce, but I wanted to show you the steps of getting a common denominator with monomial, like 28. And so as opposed to doing it when we have a binomial for the first time. And so the steps are to factor the denominator. And so I know that this is a monomial, and so when you factor a monomial, you prime factor it. And it's different if you have a binomial or a trinomial or for something that has 4 terms, how you factor it. And don't worry, I have examples like that for us to do coming next. But I'm going to prime factor these. And so this is 2 times 2 times 7. So that's 28. Minus, and then this is 5 over 42. 6 here, I'm going to write it. 42, I'm thinking about prime factoring it, 2 times 21, and 3 times 7. Now, one thing that you could do is that you can reduce as well if it's helpful. And so I'm looking at wanting these denominators to be the same. And I notice this has 2 2's, and this one only has 1 2. But I'm thinking about the 6 that I have up there, and I'm thinking, you know, I can write 6 as 2 times 3. I'm going to do that. And then I can reduce out a 2. And now I'm a little bit closer to having a common denominator, because the only thing this denominator has that this denominator, well, vice versa, that this has something extra that this doesn't have. Do you guys notice what it is? Yeah, they both have a 2. So they're good there. They're the same. They both have a 7. So they're the same. But what's missing is a 3 in this denominator here. So what you want to do to make equivalent fractions there, and the common denominator is 2 times 3 times 7, right? So the least common denominator is 2 times 3 times 7, which is 42, right? And so what you want to do is you want to multiply here top by 3 and the top and the bottom by 3. Now that makes equivalent a fraction when you do the top and the bottom by the same thing. So this is going to be 9 over 42 minus 5 over 42, right? And in fact, you could leave it if you wanted as 2 times 3 times 7 just for a second. But 9 take away 5 is 4 over 42, right? And remember what 42 is. It's 2 times 3 times 7. And 4, right, do you guys agree, is 2 times 2. And so the 2 cancels with the 2. So I get 2 over 21. And of course, because they're numbers, you don't usually do all this writing it out, right? I crossed this out when I changed the 4 into 2 times 2. You don't normally do that with numbers. You usually say to yourself, I'm going to divide out of 2 or whatever have you. But when you have binomials and trinomials, that's actually how you want to do it, is you want to factor them so that you can just say, well, this is exactly the same as that. Okay, so we did a lovely job on that, 2 over 21. Okay, so here's ones that don't have common denominator. So what you want to do, this is monomial too, just like that was a monomial. And so I'm going to leave myself some space. 3 over a plus, and then 2 over a times a minus 1 over a times a times a. And I want these denominators all to be the same. And I kind of noticed nothing will reduce. 3 in the a won't reduce. 2 in the AA won't reduce. And 1 over AA won't reduce. And usually you don't have things that reduce. But if you did, you could reduce it. And I kind of notice, well, right here, I have 2 a's. So if I multiplied the top and the bottom by a, then I'd have 3 a's, just like this one. And that would be, they would be the same then. So if I multiplied here, times a, and then times a, that makes them equivalent when you do the same, when you multiply the same thing to the numerator as you do to the denominator. And what would I have to multiply this one by so I get the same? Well, you want 3 a's, you only got 1 a, so you have to times it by a times a, and times a times a. Is that okay? Now, if you're saying I times it by a squared, well, that's what a times a is a squared, right? And so here I get 3a squared over, and a times a times a is a cubed, right? Plus, and then 2 times a cubed minus 1 over a cubed. And now I'm saying to myself, oh, all the denominators are the same. Same. So I can add and subtract the numerators. So this is, I don't know why I wrote a parenthesis, but I did. So this is going to be 3a squared plus 2a minus 1, all divided by a cubed, the same denominator. Now I know this is not going to reduce because this is a trinomial, and trinomials do not reduce with monomials, size matters, unless the trinomial has a greatest common factor that I could factor to the front. So the greatest common factor of this trinomial is 1. Now I could factor this trinomial possibly into a binomial times a binomial, but to me there's no reason to do that because it won't reduce with the monomial that's in the denominator. So there's my answer. If you factored this into a binomial times a binomial, then that is another, I mean, if it works, if you did it, that's another good answer. So I can see that the denominators here are not the same. A plus b is not the same as a cubed plus b cubed. And this is a binomial, and that's a binomial. And so what they're telling us to do so that we can get the denominators to be the same is to factor the binomials. Well, a plus b doesn't factor, so this is just 1 over a plus b. And I'm going to leave some room, plus, and then 3ab. And then I'm looking at, well, how does this factor? And I noticed, well, it's a binomial and it doesn't have a greatest common factor. It's not a difference of squares, but it is a cube. So I'm going to use the cube formula to factor it. And so I sing a song. You can sing the song if you want to. Finger over threes, write what you see. So I'm factoring a plus b. Then it goes square. Take the first thing and square it, so a squared. Multiply them together and square, so b squared. And then the song ends abruptly, soap. Same as you started with, opposite, always positive. Now this won't factor any further because a plus b won't factor, and a squared minus ab plus b squared is a prime trinomial, right? Every time that you use the cube formula, you have a prime trinomial. And so now I'm looking and I want the denominators to be the same. And I notice they both have an a plus b. But this guy has something extra, right? It has a trinomial extra. My cat's going crazy over the hummingbirds outside. And so I'm going to multiply by the denominator by a squared minus ab plus b squared. So I'm going to multiply the denominator here by a squared minus ab plus b squared. And then I'm going to do the same to the numerator, because what you do to the denominator, you do to the numerator, and that makes an equivalent fraction. And so now the denominators will be the same. So my new numerator here is 1 times this, which is a squared minus ab plus b squared. And my denominator is, oh, that's the pencil that doesn't have any lead in it. And my denominator is this. And the denominators are the same. So since the denominators are the same, you can add the numerators. You don't make the denominators the same when you're multiplying fractions, and you don't make them the same when you're dividing fractions. You make them the same when you're adding them or subtracting them. And so when I add this stuff together, a squared minus, this is 1ab plus b squared plus 3ab, right? This is a squared minus 1ab plus b squared plus 3ab, all over the same denominator, which is a binomial times a trinomial, a plus b, a squared minus ab plus b squared. And then you can combine like terms here, right? 1ab plus 3ab is 2ab. And the descending order that would go here is that you want it in descending order so that you can try to factor it. And I noticed that a lot of students, when asked to put things in descending order and they have two variables going around, they're not sure exactly what to do. And what you do is, because A is lower in the alphabet, you want to write A, the highest power of A first, so in the first spot. And so as the lead term. So that's a squared. So this is only a to the first, and this is no a. So the order I want them in is a to the second, a to the first, and no a. And you notice when I combine these like terms, that's going to be a to the first. So this is going to be a squared plus 2ab plus b squared over this. So now all we have to do is reduce, right? So we've done all these other steps, and I noticed that I didn't give myself enough room, so I'm going to go up here. And how you reduce, how you simplify, is you factor the numerator and you factor the denominator, but you notice that because we didn't multiply the denominator together, that we don't have any factoring to do in the denominator. It's already factored. So that's good. The numerator, we did multiply the 1 here in, and you needed to multiply it because otherwise you wouldn't be able to combine like terms. Not that 1 is really that big of a deal. Maybe we'll have something different down here so that we can really talk about that. But I'm trying to factor this, and I'm thinking it's a trinomial, right? And so a squared plus 2ab plus b squared, and I think this is going to be a times a, right? And here, it's definitely b times b to make b squared. And this is how we get the middle, ab, right? Now I want to work on getting the numbers. So this number right here is, I'm going to write it in pink, in fact. This number right here is 1. And so I'm thinking of numbers that multiply together to give 1, but add to give 2. And so, yeah, 1 and 1, right? And so because you don't have to write the ones, 1b is the same as b, and 1b is the same as b, but you can now see 1 and 1 is 2, right? So we got it. The signs, this says same, and this says both positive. Okay, so now we're on, we've got this factored, right? We're going to put this in our numerator. A plus b times a plus b. And then our denominator is still the same. A plus b times a squared minus ab plus b squared. And so this will, same size, right? So this is a binomial and a binomial that are exactly the same. So you can divide them out. You get 1. So I get in the numerator a binomial and in the denominator a trinomial. Neither one of my binomial and my trinomial will factor. So I'm done. They're not even the same size. Can't reduce them with one another. So we did a lovely job on that one. And we've got some more to do. And so we'll do them here. This is problem 45 out of your book. And if you wanted to pause the video and try it, because it's an odd problem, usually I say the evens are mine and the odds are yours. You could certainly do that and then pick up and see how it goes. So the idea is I notice that I'm subtracting and the denominators are not the same. And so if the denominators are not the same, then what you want to do is you want to factor them so that you can build them to be the same. And so this is just a trinomial, and so to factor this, I would have 1 times 5, which adds to 6. So that's really good, right? So this is 1 times 5, right? This is the first working, a times a. There was no greatest common factor. The signs are the same, right? Same, both positive. So this thing factors here to be 4a divided by a plus 1, a plus 5. So this would not reduce with this. And people love to reduce it, but this is a monomial and this is a trinomial. They're not even the same size, so they won't reduce with one another. When I factored the trinomial, it didn't have a greatest common factor. It factored into a binomial times a binomial, which this is a monomial, so it still won't reduce. I'm going to leave room. You know what I'm leaving room for, right? I'm leaving room so that I can do something to the top and the bottom, right? And have room to write it and not have to rewrite the whole thing. So same thing here. Monomial, trinomial. Can't reduce them. So I'm going to factor the bottom because the denominators need to be the same. 1 and 4. So this is a plus 1, a plus 4. And these are like next door neighbors, and they want to have exactly the same denominator, right? And this guy looks over at his neighbor and he says, hey, we both have an a plus 1, so we're equivalent there, but we don't both have an a plus 4, and I'm missing an a plus 4. So that's what you want to do to this one, is you want to times it by a plus 4 in the numerator and also in the denominator. And over here, right, so this guy's over there and he's saying, well, I was noticing that we both have an a plus 1, and now we both have an a plus 4, but what I don't have that you have is a plus 5. So I need to multiply the denominator by a plus 5 in order so that they'll have the same three pieces, a plus 1, a plus 4, a plus 5, right? And what you do to the denominator, you have to do to the top, you have to multiply by the same thing. You can only multiply and divide. We haven't done a divide one, except for that one that was with the numbers, right? We did a divide from the beginning there on that one, but I don't normally see that in polynomials. Okay, now the denominators are the same. And so this is the denominator that's the same, right? It doesn't matter the order that you write it in. And nothing's going to happen to the denominator from this point on. Now that we made them the same, it's all working with the numerator. You're going to, what you want to do is you want to subtract these numerators over the common denominator. A plus 1, doesn't matter the order, a plus 4. So I could have chosen an order that's not either one of these if you would have wanted. I decided to write it 1, 4, 5, but it doesn't make any difference. I could have said to myself, okay, I started with A1, A plus 1 on both of these. I'll start with A plus 4 just to make them different. But it's the same. These are the same. Order doesn't matter. And so when I go to try to subtract these numerators, you have to multiply so that you can subtract the like terms. So I have to multiply here, and this would be 4a squared plus 16a, right? This is not written close together. You're used to it written like this, but that's what it is, right? 4a times this. You're used to it written like that. So I distributed that. And then minus, now this minus right here, I want to say to myself that it goes right here with the 3a so that I can distribute the negative. And I mean, my choice would be to hold it, distribute, and then distribute the negative. And so I'm thinking I'll do it at the same time. And so this will be, I'll get the same answer, minus 3a squared. And then minus 3a times positive 5 is negative 15a. And then we're looking here, let's see, 4a squared minus 3a squared is a squared. And 16a minus 15a is 1a, or just a. All over the common denominator. And then how you reduce it is you factor, right? Pizza, I think is, the guy was really saying factor, even though it sounded like pizza to you. But I think that's what you need to do. You need to factor the top and you need to factor the bottom. And like, good news, the bottom's already factored. Good news, the numerator is a binomial, right? So I'm thinking binomial. So this is my thought, right? My thought. And I'm thinking, well, binomials have greatest common factor, or difference of squares, or a cube. What's this one? Yeah, it's greatest common factor, right, of a. So a plus 1. A times a is a squared. A times 1 is 1a. All divided by, and you see something that will reduce out, right? So right here, this and this are the same. So I'm going to reduce them out. I'm really dividing. A plus 1 divided by a plus 1 is 1. And then a times 1 is a. Now this monomial a will not cancel with a binomial a plus 4. They're not even the same size. You have to be first the same size. Monomial, and or binomial, or trinomial. And then you have to be exactly the same after that. So monomial and binomial are not even the same size. So the numerator, I'm almost out of room, so I'm going to write it out here instead of going straight down, just because, see, I'm going to be writing on my tablecloth here. I have a times 1 is a over a plus 4 times a plus 5. And that's a 4. And that's my answer. Nothing more can be done. So we did a lovely job on that. Okay, my friends, this is the now famous problem 50 and all its woes. And so I noticed that I'm subtracting, the denominators are not the same. So what you have to do is make the denominators the same. How you make the denominators the same is you factor them. And so that you can kind of see the pieces. So I'm going to kind of factor here just because it might take a little bit of room to factor it. So this could be x times 2x, only one possibility, 1 times 3. This says the signs are the same. And this says both positive. So when I fit this down here, x, 2x, plus, plus. Now I want to make 5, and I know it's going to add to make 5. And if I put the 3 right here, do you guys see how that'll already be too big? Because when you do the inner, so you don't want to put the 3 there. I want to put the 3 over here, and the 1 here. And then now that's going to make on the inner plus 2x. And what I'm going to have on the outer is plus 3x. And when I add those together, I get the 5x. Now, of course, the first is working. X times 2x is 2x squared. And then the outer, then the inner, that was working. And the last is working. 1 times 3 is 3. So I got that factored. So I'm going to put that over here. 5x plus 3, that's the numerator, all divided by the denominator I just factored. So this is equivalent. This and this are equivalent to one another. This is my work, right, to get it factored. So this is like scratch paper to me over here. I want to do the same to the other one. So I want to factor it. So here I am. I factored. And I'm going to factor here as well. Hi, Susie. Yeah. What are you doing? My cat is saying, enough for today. X times 2x. Possibilities are 1 times 6 and 2 times 3. For the same reason, the signs are both positive. They're both positive here as well. And so when I fit this together, both positive. That's not a guess. There's only one possibility there. But now I have to figure out, is it 1, 6 or is it 2, 3? And I know that I shouldn't be able to put the 6 here because that will be way too big to make 7, because that's already bigger. That's 12, right? 6 times 2 is 12. And you can't put the 6 here because it doesn't have a common factor for all terms. So I know it's not 1, 6. So how about 2, 3? Well, the 2 can't go here because then it would have a common factor of 2. So the 2 would have to go here, and the 3 would have to go there. And so let's see if it works. So on the inner, I get plus 4x. So I'm hopeful. And on the outer, I get plus 3x. And when you add those together, you get 7x. Now my first is still working, and my last is still working. So that's how that factored. I want to leave some space here, minus. And then I want to leave some space right here. And I'm going to have 3x plus 9. And I'm going to have down here x plus 2 times 2x plus 3. Okay. And I know that just got into that just because that's just how my day's going. And I'm not going to shoot it again for my neatness. I'm not. I'm done. I'm tired. Okay. So now it would be, if this factored and reduced with one of these, that maybe would be helpful, but it doesn't. That doesn't, right? That doesn't factor. This does factor. 3x plus 9 has a common factor of 3, but it won't reduce with something in the denominator. If it reduced with something in the denominator, that would be a helpful thing to do. But this would be 3 times x plus 3, and that won't reduce with x plus 2. So nothing reduces here. So now I'm just building the common denominator. So they are the same. They both have an 2x plus 3. But this one doesn't have the x plus 2, so you need to x plus 2 it. So I went and got this pink pen. So I need to, parentheses are implied here, I need to x plus 2 it, top and bottom. This is 1. And what am I missing here? Well, I'm missing x plus 1. So x plus 1 it. I'm sorry that I got into that there. And the denominator, I don't want to multiply it together, but the numerator, I have to multiply these things together. I have to multiply this times this, which is FOIL, in order to then FOIL this, so I can subtract the two things. So I'm going to be multiplying this together. So that's 5x squared plus 10x plus 3x plus 6. All over, it doesn't matter what order you write these three binomials in, x plus 1, x plus 2 if you like, 2x plus 3, great, minus, and then I got to FOIL that together. So 3x times x is 3x squared, plus 3x, plus 9x on the inner, and on the last plus 9. All divided by those same three things. I'm going to write them in the same order. Order doesn't matter, but just so that I can show you. See, they're the same, the denominators. So now parentheses are implied right here, and I need to distribute that negative through those four. But actually, I think I want to tell you, and I don't think I want to write the whole thing again, just because 3x plus 9x is 12x. So I'm going to cross this out. Well, maybe I'm going to cross it out, I don't know, and put plus 12x there, right? And so, and here I'm going to do the same. I'm going to skip a step here, and I'm going to write 13x plus 13x. So, combining like terms. So I have here 5x squared, this is a bad pencil, plus 13x plus 6. And then I'm going to distribute the negative. So a negative times here is negative 3x squared. A negative times a positive is negative 12x. A negative times a positive is a negative, all divided by those same three. Now I'm going to combine like terms. 5x squared, take away 3x squared is 2x squared. 13x take away 12x is x. 6 take away 9 is negative 3 over this. And now I'm on reduce. And how you reduce it is you factor the numerator and you factor the denominator. And good news, this is already factored. So when you're reducing, it's factor, factor. And I hope I didn't already tell the joke about pizza, right? And this is already done. So I am now trying to factor 2x squared minus 1x. I'm going to write it as a 1x minus 3. So this could be x times 2x. So I'm just kind of doing it on my side piece of paper so that you can see that I'm just factoring it the way I did in the previous chapter. Now the signs are one of each, one positive and one negative. So there's only one possibility for the first, x and 2x. There's only one possibility, the 1 and 3, but I got to figure out where the 1 would go and where the 3 would go. If I put the 3 here, then I'm going to make 6, and I think that's not going to make my 1 again. So I'm going to put the 3 here, and I'm going to put the 1 here, and let me think on the signs. I want it to be negative, so I think this is negative and this is positive, and then I want to check it. On the outer, I get negative 3x. And on the inner, I get positive 2x. And when I combine those together, I get negative 1x. So this thing factors as x plus 1 times 2x minus 3 divided by x plus 1 times x plus 2 times 2x plus 3. And the only thing that reduces out is the x plus 1. You have one of those in the top and have one on the bottom. These are similar to one another, but they're not the same. And I can't factor them to make them the same either, because you can't factor out a negative 1 and have it be that, right? So they're just not the same. So my numerator has 2x minus 3 in it, and I don't have to write the parenthesis. And my denominator has x plus 2, which I do need the parenthesis, and 2x plus 3, and I need the parenthesis. So there's my answer there. And yes, these things are, they're a lot of work. I mean, look at all that work that I did to do that problem. Okay, so that is the end of 7.3.